So, welcome to the last lecture of the course of blockchain and its application. So, in the last lecture, I was introducing you with one of the problem that we are trying to solve at our lab, and I was just sharing our thought process of approaching that problem. So, we discussed about that what are the challenges that we have and the open research questions that we had, and in this particular lecture we are going to see that how we have solved those two problems. We will continue with the topic where we stopped in the last lecture. So, the concepts covered and the keywords are pretty much similar that was there in the last lecture. So, in the last lecture we are talking about these two particular problem. We have understood that we can model the consumer with the help of a public blockchain and the service providers with the help of a private blockchain, but the requirement is that the consensus information need to be transferred from the public blockchain to the private blockchain. So that the service providers in the private blockchain, they comes to a consensus on the consumer request as well as the ordering of the consumer request. And then once the service provider process that request, generate some response out of it, there need to be a kind of verifiable way to transfer that response back to the public blockchain, where this consumer would be able to validate that the response which have been posted on the public blockchain that came through the consensus mechanism of the private blockchain. Additionally, certain response from the service providers might be private, like once you have booked up a hotel or booked a airplane, the corresponding ticket of it. Well, so we need to ensure a mechanism through which we will guarantee that only the intended participant would be able to access that response. Okay. So, these are the kind of requirements that I have. Now, let us discuss, or let me try to highlight that how we have approached these two problems. So, the first problem, that means transferring information from the private blockchain to the public blockchain to the private blockchain. For that, we designed a mechanism which we call as the consensus on consensus. What is that? That is a method to propagate the consensus information from the public blockchain to the private consortium blockchain. So, the consensus on consensus mechanism works like this, that each service provider also participate in the public blockchain to receive service request from the consumers. When a transaction is committed in the public ledger, it is verified by the service provider through simplified payment verification. SPV is a standard protocol that we utilize here. And for each service request, the service providers collect endorsement through a smart contract which we call as a propagation contract. And each such endorsement goes through a BFT consensus, and when a service request receives more than 2/3 of the service provider's endorsement, that is our typical requirement of quorum in a Byzantine faulty environment, it is marked as confirmed. Well, so let me explain all these steps with the help of a simple diagram that shows this consensus on consensus mechanism. So, the consumer, they generate the service request transaction, say T1 is the service request transaction for the consumer. So, this transactions gets propagated in the network, it reaches to the miner. So, the miner mine the transaction and add that transaction to the public blockchain network. Now, in the public blockchain network, the transaction gets added to a particular block, say the block ID is B10, which is the block number, and I have an offset value O1, which actually denotes the ordering of that transaction, that in that block B10 in which order the transaction T1 appears. Now, that way the transactions from individual consumers get appended to the public blockchain and it form a public ledger. Well, now whenever it is forming this public ledger, then as I mentioned that there is this SPV mechanism, simplified payment verification mechanism, where this particular transaction is being picked up by individual service providers. Now, when individual service providers pick up this transaction, then what they does that they initialize this propagation contract and send an endorsement along with this transaction. So, they basically tells that well, this is a particular transaction that was added on the public blockchain which need to be serviced, and this is being done by every service provider to come to a consensus, and that way this propagation contract it runs a BFT consensus mechanism, so that every service provider collectively pick up a particular request, and it picking up the request from that public blockchain is not random. So, this BFT consensus mechanism it adds up this endorsement in a private ledger or the private blockchain that is being maintained by the service provider, and that way for every individual service providers the endorsement is getting added, and that way we check that when at least 2/3 of the service providers have endorsed this transaction and the transaction got added to the private blockchain. So, when 2/3 of the transaction, 2/3 of the service providers have endorsed that transactions, then that transaction becomes ready for scheduling. Okay. So, here the interesting fact that you can see that why we call it as consensus on consensus, that is primarily because that the consensus information which were there in public blockchain that have been picked up by the service provider, and that information went through another round of consensus on the private blockchain. So, that way the service providers they cannot independently just pick up the information from the blockchain, but all those information need to go through another consensus mechanism among the service providers, which ensures that a malicious service providers cannot simply pick up a transactions and start processing it. So, to process a transaction, to transfer a transaction from the public ledger to the private ledger, the service providers they need to collectively endorse them well, and that endorsement works as a BFT consensus mechanism, and which demand for a 2/3 quorum, and when a 2/3 quorum is formed, then only the transaction is being picked up and sent for further processing within the consortium. Now comes the second part, which is the verifiable response transfer. Well, so two kinds of information need to be transferred from the consortium to the consumer once the processing of the service request is being done. So, the first one is the consortium information such as catalog, pricing, etc. These are not sensitive information, but the second type of request, like the responses correspond to the request. So, the results of scheduling and processing the consumer request such as the digital document, that is the access credential, ticket, invoice, all these things, those are the kind of sensitive information. Now, both of this kind of data generated collectively by the service providers through private blockchains consensus process, and these consumers being outside the permission network or the private blockchain network, they cannot verify the correctness of this data. So, we need a separate protocol for validation of the consensus response by the consumers. Now, to do that verification, we use this concept of collective signal signing or COSI. The idea of COSI we talked earlier. We have seen this different way this collective signing is procedure possible. So, in this particular work, we use this BLS crypto system for aggregating the signatures of individual service providers. So, using that BLS signature, we compute a particular message digest and then find out the signature of that message digest, where this H is the cryptographic hash function and SCI is the secret key of the service provider CI. So, that way we compute the message and we generate the aggregated multi signature by combining the signature of individual participants. Well, so this earlier in the context of COSI, we have seen the SNOR multi signature. Here it is another form of multi signature, which is the BLS multi signature. I am not going to the mathematical details behind BLS signature technique. If you are interested, you can just Google it, and there are many materials which talks about this BLS crypto system. That BLS crypto system, just like the SNOR multi signature that we had studied earlier, it help us to design a multi signature scheme. So, that way we generate a multi signature out of it, and so what happens that this consortium response is accepted as valid only when you have again a 2/3 quorum on the service provider signatures. And we have seen earlier that this COSI actually emulates the behavior of PBFT. So with this 2/3 quorum on COSI, we can also ensure that the Byzantine faulty correctness against Byzantine faulty behavior. Now, the second requirement come to preserve the confidentiality. Well, so to preserve the confidentiality, a response to a consumer is encrypted using the public key. Well, now to collect the signature, we this multi-signature collection, it is carried out off chain to improve the latency. To collect the signature, we generate a communication tree like a tree kind of structure that we have seen in the standard COSI protocol earlier. So, each node of the tree, it aggregates the signature collected from its descendant, similar to COSI we seen earlier. So, fallback to smart contract based signature collection in case of there is a denial of service attack by some service provider. So, here is the mechanism for this verifiable response transfer. So, I have the private ledger. In the private ledger, I have this individual transactions. So, once a particular transaction receives 2/3 endorsement, the required endorsement, then it is sent to the scheduling contract. This scheduling contract schedule the request, and once the scheduling contract schedule the request and the response is generated, the response again goes to the BFT consensus within the service provider. Then this response is added to the blockchain. Now, once this response is added to the blockchain, I need to transfer that response through this multi-signature scheme. Now, for this multi-signature scheme, we use this tree kind of structure among the service providers. So, as I mentioned, well, so through this tree kind of structure over the service provider, the signatures, the message is being propagated from the service provider to the other node, and then following the standard COSI protocol, the signature is being generated, and once the signature is being generated, then this signature is collected in the reverse direction. Well, so this part is pretty similar to our standard COSI protocol. So, that way we get the aggregated signature. So, once we get the aggregated signature, that signed information is sent to the public blockchain. Now, in the public blockchain, the miners will mine that information. While mining that information, they will verify the corresponding information, and after verification of the corresponding information, that response is transferred back to the public ledger. Well, now, once the response is transferred back to the public ledger, then a particular consumer, it can pick up the response from the public ledger, and it can validate the aggregated signature, and if required, if it is a confidential document, it can decrypt it to get the final outcome out of it. Well, so this is the way we implement the verifiable response transfer, where the procedure goes through this multi-signature generation and the multi-signature collection mechanism, through which we ensure that the information is securely transferred from the service provider to the consortium, to the consumers, and the information is actually being transferred from the private blockchain network to the public blockchain network. In case some service providers deny or some service provider fails, then we use a separate BFT consensus mechanism, and through that separate BFT consensus mechanism, it fall back to the on-chain signature collection mechanism. Well, so that is the way, means it is a kind of fallback mechanism when certain service provider behaves maliciously. Now, what we did, that we have implemented a use case of cloud federation. The idea of the cloud federation I was talking to you initially. So, in case of cloud federation, multiple cloud service providers come together and they collectively share the cloud resources. So, on-app federation is an example of such kind of federated cloud architecture. So, in a federated cloud architecture, there can be multiple small service providers. So, one service provider, they provide the computing service, another service provider, they can provide the storage service. Now, what you can do, that you have certain service requests that you have, and that service request might go through such kind of consensus, and one particular consortium member it agree to provide the computing resource, or another consortium member may agree to provide the storage resource, and with that they can collectively decide that, well, this response might be sent back to the corresponding customer. Well, So it provide such kind of federated cloud architecture. It provides cloud infrastructure resources to the end user. It is like a infrastructure as a service kind of architecture. So what we did that we implemented a fair scheduling algorithm for allocation of consumer request among service providers. So that fair scheduling algorithm actually goes through the consensus mechanism. The consensus mechanism ensures that the requirement of fair scheduling is satisfied, and the service providers generate the output of the request, or generate the response of a particular service request based on executing that fair scheduling algorithm in a decentralized way through a blockchain consensus procedure. So, the fair scheduling algorithm typically dictates like this, that each service provider will be allocated the number of consumer requests proportional to its infrastructure contribution in the federation. So, that way the participant which will provide more amount of infrastructure contribution in the federation, they will be able to handle more number of customer request or the consumer request. So, we have done a small scale testbed implementation using Ethereum and Hyperledger Fabric and Hyperledger Barrow. So, the public blockchain interface was implemented using Ethereum, and the private blockchain interface was implemented using two different techniques, Hyperledger Fabric and Hyperledger Barrow. And to test the scalability, we have used one emulator framework which is called Mininet. Mininet is basically a network emulation toolbox that provide a kind of interface to which you can do large scale emulation. This was our general architecture of the flow. So, the consumer will request for a VM, and the service providers in the cloud federated consortium, they will run this fair scheduling algorithm, and will decide that which service provider is going to handle this VM request, and that response will be sent back to the consumer. And for that we use this kind of blockchain based interfacing that I have just described. So, this was our testbed setup. We have considered three different service providers, CSP1, CSP2 and CSP3. They typically run this Docker swarm on an overlay network. The public blockchain network was implemented using Ropsten and the Ringby test network over Ethereum. So, we have implemented this JIT client and event listener. The interface was implemented using Web3.js. We also implemented this multi-signature verifier and provided an web based GUI through which the consumer can submit the request, and then the cloud service providers, they will run this fair scheduling algorithm in a decentralized way to come up with a final solution of it and send back the solution to the consumer. And at the CSP side, we have this VirtualBox VM manager through which the VM request will be satisfied, and then we have these different components of this collab-fed architecture like the multi-signature collector, the Fabric Barrow peers, the Fabric Barrow JS SDK, the Flux server, the Web3.js interface, JIT client and event listener. This independent component have been implemented. And as I mentioned that we considered three different servers. So, these are the specification of the three servers that we have considered that have different resources with them, and they actually collectively run this collab-fed architecture through which one consumer can request for a VM, and then these three service providers, they come to an agreement about who is going to host that VM, and that response is sent back to the corresponding consumer. So, here are some results from the testbed. So, if you just look into the latency, so we tested over two Ethereum test network, Ropsten and Ringby. So, here you can see that the latency of Ringby was much less compared to Ropsten. Here it shows the latencies for number of parallel requests on Hyperledger Fabric and Hyperledger Barrow. Incidentally, Barrow worked much better in our case, and that was actually the way Fabric and Barrow does the scheduling. Well, so So they are independent nature, and that scheduling is very much a particular problem specific. Well, so for our problem we have observed that Baro works better, but for some other problem it might happen that Fabric can also work better. So it entirely depends on how the problem has been formulated. And finally, this shows the latency for multi-signature collection. So here you can see that, well, that latency is something in the order of second, and if you just compare between this individual latency, so for blockchain network the latency was in the order of few minutes sometime, so some 60 second or 40 seconds, something like that, and for multi-signature collection it is some 4-5 second maximum at max. So that way this component is not very significant, rather the significant component is was that running consensus on top of this public blockchain network and the private blockchain network. And on average we have found that, well, once a consumer request is being made, within a few minutes you can get a corresponding response. Well, so the response is not very immediate, but you can get the response within a few minutes. Well, obviously you can ask the question that whether this few minute latency is tolerable. So it is something like that. I have requested for a VM and the system processed that request and send me back the response. Possibly for a VM allocation this request, this kind of delay is tolerable, but if you are thinking about e-commerce website or booking.com kind of Trivago kind of hotel booking services, there possibly you need to think of other techniques to reduce this latency further. They are possibly this kind of latency in the order of minutes is not acceptable. So in conclusion, what we see that there are interesting research and design problems in the blockchain space. Well, but you need to think of applying the right technology at the right place. So as I mentioned that in this particular problem where I have shared our experience, we have looked into this problem entirely from the technical perspective, from an academic research perspective. We have tried to come up with a consensus mechanism through which we will be able to facilitate transfer of information from a public blockchain to a private blockchain and then get back the response from the private blockchain and send it back to the public blockchain. Well, but there are multiple different questions which remain that say for example, you have paid the money in a say for example, you use such kind of architecture to generate e-commerce website. Now in that e-commerce website there is one service provider. Apparently that service provider looks good, they have not done any kind of malicious or fraudulent behavior yet, and what you do that you place your order to that particular service provider and then that service provider starts doing the malicious behavior. The example that I have given you earlier, that you have ordered for a smartphone, but you receive an empty box. So the question comes that what you are going to do after that? Well, one possibility is like you can lodge a complaint to the consumer forum because you have the identity of that particular seller where you have put up the contract. So and the seller identities have already been verified as we have assumed. So there are certain trusted way of verifying the seller's identity. It might be through another identity network in a blockchain or through some trusted party, trusted third party, but that identity is verified, that you can assume. But then you have to lodge up a complaint in the consumer forum. The consumer forum will validate that. You have to prove that you have received an empty box, not a mobile. So the question comes that how you are going to validate that, how you are going to put up a proof for that. So this kind of questions remains, and typically in our day-to-day life, in our day-to-day experience, what we have seen that if such kind of problem occurs that you have booked certain service over Amazon, over Trivago or over booking.com, and some problem happened and you called the service provider, they immediately solve the problem. Okay, so for example, in case of booking.com, it actually happened to me once. I was traveling to some place in Italy, in Sardinia. I booked a hotel in booking.com, and when I reached there, I found that the hotel is closed. Something happened. So some legal cases, something happened with that hotel, and they suddenly closed it, and they have not inform that to the booking.com owner. So at that point of time, immediately I had made a call to booking.com, and booking.com take up my request, and they have immediately allocated me another hotel, and indeed a better hotel. So it was a 3-star hotel, and I got a better hotel out of it, and they have not taken extra money from me. Well, so that way I got my service somehow. Well, obviously I have to wait for some time, for a couple of hours, but I somehow I have been able to manage it. But in this case, if you just think of that, it is a kind of complete decentralized architecture, right? And you have booked a hotel, you got a confirmation, and when you reach the destination, you found that the hotel is locked. What you are going to do? You have no one to complain at that time, right? You don't have any phone number where you can complain, because there is no one centralized who is managing that entire service. So that is a kind of practical challenge, practical implementation kind of challenge for this kind of problem. And if you think carefully, for many of the blockchain based solution, whenever we are talking about such kind of decentralized marketplace, decentralized way of managing the stuffs, it looks good, but sometimes it might put up more overhead from the end user's perspective. So that way, I think it is a good time. We have already understood that what type of services or what type of applications can be built on top of blockchain, and there are millions of documents which actually describe that. But then what are the real challenges that can come while you are going to practically implement it? So I think it is the high time that we should think about that, and we should try to find out a solution of it. Well, so unless we are able to find a solution of it, possibly none of these applications can be implemented on top of blockchain. Well, we need to carefully think of such kind of problems. So that way, as I mentioned earlier, that whenever you are thinking to build up a solution on top of blockchain, you should remember such kind of fundamental questions that we have talked about earlier. That who are your network, what is the network, who are your participants, what are the assets that you are going to transfer on top of blockchain, what are the transactions that you have, what are the keys that you are going to own, how to obtain those keys and how to share those keys. Do we have any kind of trusted third party in the system? So what is the limitation of the trusted third party, what level of trust or what level of service it can provide, and finally that why people are going to join in your blockchain network. And at the same time, you need to think of this question that, well, whether there can be any side channel in my blockchain based system through which a particular customer gets suffers or a particular user gets suffers. Well, so in that case, if the user doesn't have any guarantee, so today we book a hotel from booking.com or book a airplane ticket from Make My Trip, thinking about that, well, if some dispute happens with me, that then booking.com or Make My Trip is going to resolve that dispute. Well, but in such kind of decentralized marketplace, if such kind of dispute happens, then we don't have any kind of identified authority who can resolve that dispute on an immediate scale. And the example that I have given regarding hotel booking, such kind of dispute resolution sometimes need to be very fast. Well, you can say that the consumer forums you can put up a complaint, but that will take its own time. So the question comes, how can I get a immediate dispute resolution in case I face such kind of problem over a decentralized marketplace, because I do not have any authority or someone who can lead the system, who can take over the system whenever required. Well, so these are the kind of open questions that we have, and as I mentioned that you should always think of whether blockchain is the best solution to solve the problem, solve the use case that you are thinking about. Well, if you strongly feel that blockchain is the best solution, and if you can answer all these questions, if you can find out that, well, such kind of problems, such kind of side channels doesn't appear if you are developing a solution with the help of blockchain, then I would suggest go ahead with it. Otherwise, you need to really think of an alternate solution. Maybe you can think of blockchain coupled with something else, and accordingly you can have a low cost solution which can possibly balance between all these requirements. So with that, I conclude this lecture as well as conclude this course. So, I hope that you have enjoyed this course and you have been able to learn the basics of blockchain, its internal structure, as well as got an idea that what blockchain can deliver and more importantly what blockchain cannot. Well, as I mentioned multiple times during the course that you do not have a free lunch anytime. So, every technology that comes, it has its own limitation. So, rather than jumping behind the hype of blockchain or jumping behind this kind of buzzword, we should carefully think of what this particular technology can deliver, what is the advantage that we will get, and at the same time I should carefully think of what is its limitation, and by doing a trade-off analysis between this advantage and the limitation, we should finally decide whether we should approach it or whether we should take this particular technology to solve the problem that we are facing or not. Well, so that is all from my side. Thank you, and I hope that again you have enjoyed this course. See you again. Take care.